All right, so we are going to start the exam preparation series for Chem 102 with the first topic here. And the first topic here is on chromatography. Now the question is, what is chromatography? This is a very simple something, and I want us to listen attentively. Now chromatography is a separation technique. Now when you say something is a separation technique, what do you mean? It means it is used to separate different components. Are you getting it now? It is used to separate different components, hence the name separation technique. If you have a mixture of compound in one and you want to separate that compound into its different components, then you can use chromatographic technique. Are you getting it now? So we have here that chromatography is a laboratory technique used for the separation of mixture. The principle is based on differential partitioning. Please emphasis on this. What is the principle of chromatography? You are going to be asked a question like this. What is the principle of chromatography? The principle is based on differential partitioning between a mobile phase and a stationary phase. So every chromatographic technique involves a mobile phase and a stationary phase. Is that okay? The principle is based on differential partitioning. When we talk about differential partitioning, we are talking about some of the components will be on the mobile phase, while some will remain on the stationary phase. You've partitioned it. Are you getting it now? If you have a mixture of A, B, C, D, let us say situation where A and B remain on the stationary phase, while C and D is on the mobile phase, you say you have what? Partitioned it. Are you getting it now? So that is what the chromatographic technique is all about. Now, another thing is that the component of the mixtures move at different rates, leading to separation. Leading towards separation. Let me just explain a simple chromatographic technique like the paper chromatography you guys did. Now, this is the stationary phase, which is made up of a paper. Now, what you guys did was to rule that paper under, and then you spotted, right? You spotted different, a mixture of different color. Let us assume this is what you spot, and then same here, you have black in this mixture. Same here, you have green. Same here, you have red. So remember this, we spotted different colors here. Red, green, black, and which other color again? Basically, these three colors, purple. Now, what chromatography is this paper here is what we call the stationary phase. All right, this is the stationary phase. Then you are going to dip this in a mobile phase, which is water. Mobile phase. The mobile phase is inside this tank. The tank is called the chromatographic tank. Are you getting it now? So this is the mobile phase. Now what will happen is, via capillary action, we talk about capillary, like as you dip this paper inside here, the water or the solvent is not necessarily water. The solvent, which is the mobile phase, will start moving up. And as it is moving, it helps separate this color into their individual components. So in this case, you are going to have different components. Remember, we had green. So you are going to have green separated. We have this purple here, which will also be separated. We have black, which will also be separated. And then we have red, which will also be separated. So what is separating it is actually the mobile phase. As the mobile phase is moving, it is moving with the different components. Are you getting it now? Remember that all the components were initially here, but as it's more like erosion, where water is washing things away. Are you getting it? So the water is actually washing these colors as it's going up. It's moving them from this position to a later position. Do you understand the concept? And the more soluble this component is to this, I'm using water, the solvent rather. The more soluble this component is to this solvent, the more it will move it far away. Are you getting it? Far away. So the component of the mixture move at different rate. That is why they are separated. Like this one now, you know that this one is moving very fast. Hence, it is separated first. Are you getting it? This one is moving also fast, but the green one is moving very slow. Are you getting it now? So why the red don't reach here, the green one still dey here. So the separation is based on the different rates of movement and the partitioning between the mobile phase and the stationary phase. Now what this means is that this red one has more affinity for the mobile phase. That means the red and the mobile phase, they blend well. Now why the mobile phase easily fit move this red to this position. You remember that as this thing is moving, the mobile phase is also, as the mobile phase is moving, that is how it is moving all this thing. Let us assume the mobile phase ended somewhere around here. It carried the red reach here. It means the mobile phase and the red, they actually have a lot of affinity because it was able to carry it to this point. Why the mobile phase and the green no to get affinity like that. That was why even when the mobile phase was moving, the green still remained stagnant at that position under there. Do you get it now? So you will now say that the green has more affinity for the stationary phase, while the red has more affinity for the mobile phase. When you talk about affinity, it's more like likeness. Is that understood? So that is the general idea on chromatography. Now, the principle of chromatography, we stated the principle that the basic principle of chromatography is the distribution of solute components between a stationary phase and a mobile phase. Is the distribution between a stationary phase and a mobile phase. And components with a higher affinity for the stationary phase move slower. That was what I was trying to tell you, that this green here has more affinity for the stationary phase, while the red has more affinity for the mobile phase. So this one, the red will move very fast, while the green, which has more affinity for the stationary phase, will remain with the stationary phase. Are you getting it? Even if it moves just a little bit. Now, component with higher affinity for the stationary phase moves slower. So this is a question that you might be asked also. In chromatography, which of the component moves slower? It is the one with what? Higher affinity for the stationary phase. Why those with higher affinity for the mobile phase move faster? Are you getting it now? So the one with higher affinity for mobile phase move faster, while the one with higher affinity for the stationary phase move slower. So this one with the higher affinity for mobile phase, they will come out first. They will be eluted first. You are going to look at the meaning of elution as time progresses. Now let us look at the types of chromatography briefly. All these ones, there are potential questions that will be given to you. Now, chromatography is broadly classified based on the phases used. Are you getting it? And our classification, we have classification based on various criteria. Are you getting it? Now, based on the physical state of the phase, we have gas chromatography, liquid chromatography, and supercritical fluid chromatography. Now, like we said, that every chromatographic experiment has a mobile phase and what? A stationary phase. Please take note. I have taught you something like this on chromatography before. A mobile phase and what? A stationary phase. Is that okay? The phase that move, which is the solvent, is the mobile phase. While the stationary phase is the phase that is not moving. Are you getting it now? Now, the mobile phase can be a gas, a liquid. While the stationary phase can be, most time liquid and even solid can be part of the stationary phase. Is that okay? Now, we want to classify chromatography based on the physical state of the phases. We have what we call gas chromatography. Now, as name implies, the gas chromatography the mobile phase is a gas and the stationary phase is a liquid or solid. Are you getting it now? For gas chromatography, the mobile phase is a gas and the stationary phase is a liquid or solid. Liquid chromatography. As name implies, liquid chromatography, the mobile phase is a liquid, while the stationary phase is either a liquid or solid. Are you getting it? Supercritical fluid chromatography. They use supercritical fluid like CO2 as the mobile phase. So based on the physical state of the phases, we have gas chromatography, liquid chromatography, supercritical fluid chromatography. Based on the physical state, what do we have? Gas, liquid, supercritical fluid chromatography. Now, another one is based on the mechanism of separation. The first one we said is based on the physical state. Now let us look at based on the mechanism of separation. Based on the mechanism of separation, we have adsorption chromatography. Now when you talk about adsorption, the something is attached to the surface of another. That kind of chromatography is called adsorption chromatography. Example of adsorption chromatography is thin layer chromatography. That is an adsorption chromatography. Partition chromatography. Then this one, the separation is based on solubility differences between the components and the mobile phase and stationary phase. This is where paper chromatography comes in. Paper chromatography is an example of what? Partition chromatography. The component partition between the solvent and the paper they use. The paper, there's a thin fluid inside that paper that is used, the Wärtsilä #1 paper. All right, so that is that. Then we have ion exchange chromatography. This one, the separation of charged molecule using ionic interaction. As the name implies, ion exchange has to do with what? Molecule. Then size exclusion chromatography. Separation is based on the molecular size. It's more like filter. The ones with low molecular size will come out first, while the one with high molecular mass will be retained. Then affinity chromatography. Then this one, the separation is based on specific binding interaction. Now, nobody will ask you detail on this. They might just ask you which of the following is not a type of chromatography, so you should be able to distinguish them. Are you getting it? Know that paper chromatography, which you did in the lab, is partition chromatography. Is that okay? Then ion exchange chromatography, size exclusion chromatography, affinity chromatography. Know these ones. Then the next one is based on mechanism of separation. We've talked about partition chromatography. This one is based on solubility difference, ion exchange, separation of charged molecule, size exclusion, separation based on molecular size, affinity, separation based on specific binding interaction. Is that okay? Then the techniques of chromatography, based on the technique that is used. We have paper chromatography. This one uses paper, filter paper, as the stationary phase. Is that okay? What kind of filter paper? Is Wärtsilä #1 filter paper. That is the paper that is used. You might be asked, what paper was used for your paper chromatography? Are you getting it? It's Wärtsilä #1 that was actually used. Is that okay? So that is that. Now, column chromatography. This one uses a packed column as the stationary phase. The packed column comprises of silica gel. All right? These are some of the things that you will see later on when you start studying, especially those of you in pharmacy. Then gas chromatography uses gaseous mobile phase for separation. I'm just trying to tell you that we could have paper chromatography, thin layer chromatography, column chromatography, gas chromatography. Because the options that the reason why I'm actually teaching you this is not for you to know in detail what each of them entail. No. It's so that when options come, you know that there is something called thin layer chromatography. Are you getting it now? Then column chromatography, then gas chromatography. Is that okay? Exactly. Now, we have the question here. Say chromatography is mainly used for separation of mixture, synthesis of compounds, separation of mixture, breaking chemical bonds, changing the state of a substance. I've told you that chromatography is mainly used for separation of mixture, right? The principle of chromatography is based on differential solubility, that is correct. Differential absorption, that is also correct. Differential migration, that is also correct. Because we said, based on principles, some use solubility, some use absorption, some use what? Migration. So the correct answer is what? All of the above. Are you getting it now? All of the above. Then the next one. The phase that moves in chromatography is called the mobile phase. Is that okay? It's a very simple something. Why the phase that remains is called the stationary phase. In your paper chromatography, the mobile phase is your solvent that you use. While your stationary phase is that paper. There's a thin film of liquid on top of that paper that you cannot see. Are you getting it? There's a thin film of liquid on top of that paper that is not obvious. So the phase that moves in chromatography is the mobile phase. The phase that does not move is the stationary phase. Now, in paper chromatography, the stationary phase is made up of cellulose. Are you getting it? It's a thin film on top of the paper, not necessarily that paper itself. Cellulose. You know, paper is made up of cellulose starch. Are you getting it? So in paper chromatography, the stationary phase is the paper. In the exam, they might just give you a paper because they don't want you. You guys are not big enough to distinguish between some of these things. Are you getting it? So you might just see paper there in the exam. Now, gas chromatography is best used for. Now, gas chromatography are used for substances that are volatile. When you say something is volatile, it means it can turn to a gas. The principle of gas chromatography will be discussed probably when you guys get to year 3, year 4. But it's basically used for volatile substances. Something that can change to what? Gaseous phase. Now, thin layer chromatography uses dash as a stationary phase. I have said that thin layer chromatography uses silica gel. Look at it here. I said something like that. It uses silica gel as the stationary phase. See here. Thin layer chromatography uses a thin layer of adsorbent, e.g. silica gel. Are you getting it? As the stationary phase. Column chromatography also uses silica gel as the stationary phase. Alright? All those on the use silica gel as the stationary phase. Now, the retention factor. Now, in all chromatographic experiment, what you are trying to calculate is the ROF. And the ROF is the distance moved by the solute divided by the distance moved by the solvent. Now, what do we mean by that? How do you calculate your ROF? After doing your experiment, you know they will tell you, let us assume that this is the distance moved by the solvent. This place here is the distance moved by the solvent. Let us assume here is 8 centimeters. Are you getting it? This is the distance moved by the solvent. So to calculate your ROF, you now measure the individual component. This red has a particular distance from this position here. This place you ruled it.